In this video, I'm going to show you how to use generator functions. When a function contains the yield keyword, it becomes a generator function. Instead of returning a single value with the return keyword, generator functions use yield to produce a sequence of values. When you call a generator function, it doesn't execute the entire function at once. Instead, it returns an iterator object that can be used to retrieve the values one by one. The yield keyword is used in the context of generators to create iterable objects that produce a sequence of values. Generators are useful for efficiently processing large amounts of data or for working with infinite sequences, where you may not know the exact number of elements in advance. They allow you to generate values on the fly, which reduces memory usage and improves performance. In my development environment, you'll see that I have a function defined, and this has the yield keyword in it, which means that it is a generator function. And you create a generator function just like any other function. You start with the def keyword, then you give it a name, and then inside parentheses, you give it any parameters that you may want it to have. And then underneath, I have num equals 0, so I'm initializing num to 0. And then I have a while loop that is going to check while num is less than or equal to limit, and it's going to execute this code here. So down below here, I'm going to create a variable called evens and assign it the value of generate even numbers, and I'll pass 4 in as a parameter. And real quick, I am going to just try to print evens. And you'll see that the values that are generated by this are not in this variable right here. When I run this, we'll see I get this output that says generator object, and then it has my function name, and then it has this at and all these characters and numbers here. This is a memory address where this function is currently residing in memory. So to actually print these values, I need to use a for loop. So I'll say for num in evens print num. And if I run this now, I get my outputs 0, 2, and 4. And the way that this is working, when we create our generator object, we have num initialized to 0, and it is going to check while num is less than or equal to limit, then yield num. So it's sending yield back to whatever we have that's going over our iterator object. So in this case, it's a for loop. And then it's going to print that value here. And then it's going to go back to the generator function and then continue from where the yield statement was. So it's going to go back to here and then drop down to the next line and increment num by 2. And then it's going to go back to the while loop. And now it's going to be 2 is less than or equal to limit. And then it's going to yield 2. So down here in my for loop, it's going to output 2 in our print function here. And then it's going to go back up into the generator function again and continue on from there down to this line, increment it to 4, go back to the loop, pass that 4 back down into our for loop here. And then when it goes back, it's going to increment num to 6. And then the loop conditional will no longer be true, so it stops generating numbers. Now let's look at a function that generates an infinite sequence of numbers. So I'm going to remove this and add in the generate primes function. There are two main variables, primes and num. The list primes will store the prime numbers found so far, and num is the number that is being checked for primality. A generator expression, this here, checks if num is not divisible by each number prime that's in the primes list. The all function then checks if all these conditions are true, and if they are all true, num is prime and it is yielded from the generator. So down here, I am going to create a variable called prime generator, and I will assign it the value of generate primes. So now I have my generator object, and then below this, I am going to use list comprehension to generate a list of primes. So I will say primes, which is going to be my list of prime numbers, and then in square brackets, for my expression, I am going to use the next function, and I'm going to pass it in my prime generator, and then I'm going to put for I in range, and then inside the range I would put the number of primes that I want to generate. I'll start with 5, and then just below this I will print my primes list out. And now when I run this, I get this output 2, 3, 5, 7, and 11, which are the first 5 prime numbers. And since my generate primes function generates an infinite sequence of prime numbers, I can put whatever value I want here. So if I wanted to generate 500, I could generate 500, and then I get the first 500 primes. Since this is all a little bit complicated, I'm going to try to explain it a little better. I'm going to change this to only output the first 4 primes. And I have a print function that I'm going to call, and you don't necessarily need to understand everything that's going on here, but basically what this print function is going to output is the num, which is the current number that I'm checking for primality, and then a list containing the Boolean values of whether or not this num is evenly divisible by each number that's in the primed list. And then it is going to output whether or not the all function is returning a true or false value. And if the all function does return a true value, that number is prime. So now when I run this, we'll get this output down here. We have our first 4 prime numbers, 2, 3, 5, and 7. And we'll see next to 2, the all function is outputting true. Next to 5 and 3, it is outputting true. And next to 7, it is outputting true. And all of our Boolean values in here where this is true are true. So 3 has a single true Boolean, 5 has 2 true Booleans, and 7 has 3 true Booleans. And you'll notice that 2 is an empty list. And this is because if I hover over the all function, it says right here, if the iterable is empty, then it returns true. And with that hopefully coherent explanation out of the way, I will try to walk through these iterations. So the first time this runs, num is 2 and our primes list is empty. So when it's saying num mod prime is not equal to 0 for prime in primes, well, this is an empty list. So this is why we get this true here. And since this returns true, it yields num, which starts out at 2, and then it appends num to our primes list, and then it increments number by 1. So the next time it goes into the loop, num is now 3. So it's saying num mod prime for each prime number in our primes list, which in this case is only 2. So 3 mod 2 is not equal to 0. 3 mod 2 equals 1. So this does evaluate to true. That's why we have this true here. And since all the values in this list are true, our all function returns true. This is a prime number. And then we go to the next number. So now num is 4, and we have 4 mod prime for each prime number that's in this list, which the first one is 4 mod 2, which is 0. So this is going to evaluate to false, which is why this first element in this list is false. And then it's going to go to 3. So it's going to be 4 mod 3, which is 1. So it is not equal to 0, so this evaluates to true, and that's why we get the true here. But since we're checking to see if all the values in this list end up being true, the all function returns false on this, and 4 is not a prime number, hence it is not in our list down here. Generator functions and the way that they are working back and forth with loops and stuff that goes over iterator objects can be a lot to wrap your head around, and I hope that I explained it in a way that made sense, and walking through the first couple of iterations helped explain how generator functions work. Generator functions are a powerful tool in Python that allow you to work with large data sets and infinite sequences efficiently. They are particularly beneficial in scenarios where memory usage is a concern. So I strongly encourage you to practice using them and think of different ways that they might be useful, and just work with them until you feel like you have a solid understanding of what they are and how they work.